we're solving two-step problems today, at least two steps, okay? And we know that the tape diagram is a good way to organize the information. So here's what I want you to think about. On number one, we're going to need 3 tape diagrams. I'm going to read the problem, and I want you to think about how we might draw those 3. By the way, in block 3, someone came up with how to do it. In a race, the second place finisher crossed the finish line 1 1/3 minutes after the winner. The third place finisher was 1 3/4 minutes behind the second place finisher. The third place finisher took 34 2/3 minutes. How long did the winner take? Now, I'm going to get you started. First place. Second place. Third place. Now spread those out. Any ideas on the tape diagrams for these 3 places in the race? Carson. Okay, but what do you mean by that, sideways? So let's say there's first place. We don't know it. That's the unknown. Okay? Take a look at second place. Now, is second place going to be a longer time than first place?
Yes.
Yeah. How much longer? 1 1/3 minutes longer. And what about third place? Is it going to be a longer time than second?
Yes.
How much longer? 1 3/4 minutes. Do we have a total? And that is the longest time. Now, I don't know what race they're running, but I'm glad I'm not running for 34 minutes. So here's what we're going to do. We know the total of the third place finisher. How will I figure out first place? I'm going from larger to smaller. So if I'm going from larger to smaller, what operation will I need to do? Subtract. So if I'm going to subtract, I want you to go ahead and write this problem down. 34 2/3 minus 1 3/4 minus 1 1/3. And if we subtract all those, we should get first place, the time of the first place finisher. Now, do you notice that this dotted line that I drew is like equal to the length of the second place and of the first place? Well, that wasn't very straight, was it? But you got the idea?
Yeah.
Okay, so now, yesterday we did some confusing problems, and I don't want you to get any more confused. But this is not the one where we added them all together to get the total. That one would have been missing the first number, and it would have had the last number. This one, we're just going to subtract. But there's a couple ways to subtract. You can subtract in order. You can add these two together. You can subtract that way, but you can't subtract these two smaller amounts first, or it's going to give you the wrong answer. So, Sari, how would you like to set this problem up?
34 2/3 minus 1 1/3.
I agree. Why'd you group it like that?
Because they both have the same denominator.
3 is the denominator. So, and then I'm going to subtract 1 3/4. Now, this is kind of tricky. So let's look at it, okay? Can I subtract that in my head? 34 minus 1 and 2/3 minus 1/3. And here we have the problem. Now I'm looking at those fractions before I do anything. What do you think? Subtract the wholes. So it's going to be,
32.
and I'm going to add that to my answer of 1/3 minus 3/4. Gabe, can you close the door, please? Uh-oh, we have a problem. 1/3 is smaller than 3/4. So all I'm going to do, I'm going to borrow 1 from this. Okay, now it's called decomposing. We did it last week. So write down 32 and what was it? 1/3. Okay, so if I borrow 1, I'll have 31 left. What would the 1 whole be as a fraction? 3/3 plus 1/3. So I'm going to change this to 31 and what? 4/3, because 3/3 plus 1/3. Now you can subtract. What's your common denominator? 12. Make sure you subtract. So what is 16 minus 9? So 31 and 7/12. So that's the time of the first place finisher. Now I'm going to challenge you just a little bit more.
We did the second place one?
No, I could, but I want this in minutes and seconds.
Oh.
Now, in order to do that, I'm going to take that fraction 7/12 and make it equivalent to blank 60th, because how many seconds are in a minute? 60. So what do I need to do? What am I doing to the 12 to get 60?
Multiplying it by 5.
So if I multiply the 7 by 5, 35 out of 60 seconds. So 31 minutes and 35 seconds. And if it's the stopwatch for the race, it would be like this: 31 ... 35, and then there'd probably be some hundredths of a second over there. Okay?
So we finished like. He's an exact runner.
31 minutes and 35 seconds. Okay, let's move on down to the second one. By the way, on Zern, and it's really giving kids problems, all you have to do is look at what we did on our problem set to figure this out. But on Zern, the only thing that's different is we know, and it's not the same numbers, but we know the first place finisher's time, and we need to figure out the third place finisher's time. By the way, what's the opposite of subtraction?
Addition.
Is this the opposite of what we just did?
Yes.
So would you add? If you know the smallest one and you need to figure out the largest one, you're going to do the same thing but add.
Yes.
All right, let's go on down to the second problem. There is a problem on your test almost exactly like this. Not the same numbers, but the same strategy. Also, your exit ticket is this strategy. So you're going to get really good at it. Okay, think about what tape diagram you would draw. Stay with me. Pick your head up. Stay with me. I hope this is not us tomorrow morning. John used 1 3/4 kilograms of salt to melt the ice on his sidewalk. Then he used another 3 4/5 kilograms on the driveway. If he originally bought 10 kilograms of salt, how much does he have left? Okay, do we have a total?
Yes.
What is it?
10 kilograms.
10 kilograms. So that goes at the top of my tape diagram. And we're trying to figure out how much he has left. How much did he use?
3 4/5 and 1 and.
So 1 3/4 was the sidewalk. 3 4/5 was the driveway. Notice those are both compound words.
Yeah.
I don't know why I noticed that. Okay, how do I solve this problem?
You're a teacher.
How do I solve this problem?
Subtract.
Subtract everything?
No. Subtract. Or you can add 1/3, 1 3/4 plus 3 5/5, and then subtract it from 10 kilograms.
Okay, here's what I want you to do. 10 minus something right down here so you don't forget that you need to do it. Now your exit ticket also has 10. All right, so to add these two fractions,
Add the whole number first.
so what is 1 plus 3?
4.
So I'm going to add 4 to my answer. 3/4 plus 4/5. Common denominator?
20.
15 plus 16.
Oh, it's adding. 31.
Okay, now, remember I told you I watched the video this morning? And here's something really clever he did. He said, we can think of 31 as 20 plus 11. And I see 20 20ths would be 1 whole. So my answer is 5 and 11 20ths. But I'm not done. I've got to subtract that from, and I want you to do it like this. 10 minus 5 minus 11 20ths. Okay, what's 10 minus 5?
5.
So 5 minus 11 20ths. I'm going to draw this. Don't say anything. That's okay. I want everyone to think through it. So 10 minus 5 minus 11 20ths. That's a little more than half, right? So 5 minus a little more than half. What's my answer going to start with, boys and girls? 4. How many more do I need to get to 20? Do 9 and 20 share a factor? No, so that's my answer. If you follow this procedure exactly, you can get your exit ticket correct and the first problem on your test done correctly.